So actually give yourself a second for it to start. 5, 4, 3, 2, 1, go.
Cool. Welcome everyone to another week of Azure DIY. So today we're making our first foray into the data space with advanced analytics for developers. Now this is the first out of 2 sessions that we have in this topic, and they'll both be presented by the wonderful Chuang Zhu from Insight. So today we'll be specifically focused on how to ingest that data in your analytics platform. And next week, technical difficulties, we'll be focusing on how to actually use that ingested data to get insights out of that and for advanced BI. So here's the session 3 schedule. So we're actually about halfway through. And then after our advanced analytics sessions, we have some sessions focused on GitHub, AI, and some HashiCorp as well. So a bit of housekeeping before we get into the content that you guys are actually here for. We do have a growing LinkedIn community, so I please do encourage you all to join. This is where we'll post all of our recordings and collateral from these sessions, as well as posting our events. So if you're not tuned into every week, this is where you'll find out the new announcements and what sessions we have scheduled for the future as well. So as I said, the session will be recorded and shared on LinkedIn. Throughout the session, please feel free to ask any questions you have in the Q&A section. So there will be about 10 minutes towards the end of the session for Chuang to answer any questions. But in case we don't get to all of them during that time, we actually do have some data and AI experts moderating the chat as well. So they'll be answering some questions throughout the session as well. We do have some exciting Azure announcements. So as many of you would know, we had Ignite 2021 last week. Specifically in the data space, we actually had Arc-enabled machine learning announced, which means that you can now run, build, and actually govern and manage Azure machine learning basically anywhere, be it in Azure, in your DC, or in a different cloud. We also have Azure Synapse Pathway. So taking a lot of the effort out of manually converting things into T-SQL during your data migration experience, you now have a tool that will automatically do this. There were many, many updates to Azure Purview as well, including compatibility for other clouds, connectors into further sources, support for private endpoints. But I encourage you to double click on the Purview updates as well as the rest of the Azure announcements in our book of news that you can see linked here. So I'll now pass on to Chuang to get into the bulk of the session.
Cool, thanks, Amanda. I'll just share my screen. Okay. I think everyone can see the screen at the moment. Hello, everyone. Welcome to another session of Azure DIY. My name is Chuang Zhu. I'm a principal consultant in the data and integration space for Insight Enterprises. A bit of background, so I've been in IT for around 15 years with an architect mindset focusing around data engineering and analytics. So I come from a normal traditional background using a lot of the Microsoft BI technologies. So for most people on the call, they might be familiar with SSIS, SSAS, and SSRS, and traditional data warehousing techniques as well. So as part of my remit recently, I've been working with organizations to modernize their data estate through various assessment activities, and then help customers in adopting on Azure for their data platform and analytic workloads. So as part of the agenda today, we'll cover some high-level introduction around Azure Synapse Analytics and how that fits in the developer landscape. We'll look at end-to-end advanced analytics architecture, and then jump into how best to architect a data lake with big data coming on nowadays with this petabytes, large sums of data that's around. How best to architect that sort of landing area to sort of enable agility within the organization. And then we'll spend most of our time talking about how to build an ingestion control framework so you can ingest data in correctly and also extensively and reusable in the future. And hopefully in the last half an hour, we can go through a demonstration that I've sort of put together. using that ingestion, a simplified version of the ingestion framework itself. So let's start with, the Azure Synapse Analytics for developers. What is Synapse? Essentially, it's a unified and unlimited analytics services with unmatched time to insight. The platform itself is obviously decoupled. So it essentially has a decoupled architecture where the storage and compute is separated. The storage is essentially backed by Azure Data Lake Gen 2 with various connectors and integrated with common data model as well. So that means if you're running various Power Platform or Biz Apps or Power Apps within the Microsoft suite, it's easily natively integrated into the data lake itself. On top of that, obviously the platform has its own sort of services for managing planes, security, monitoring, and metadata store that's also available in the data lake as well. Then within the platform, there's a data integration layer. So if everyone's familiar with Azure Data Factory, that's the core component of any integration component with pre-built connectors, all available for you to connect to on-prem, cloud, and external data sources, essentially. What's good about the compute and the runtimes? It offers two types, obviously. SQL, T-SQL, people are familiar with traditional SQL analytics, running T-SQL languages, and also Apache Spark, which is essentially in-memory compute, a lot for advanced analytics and usage of various external libraries. And the form factor. So essentially, there's three types of compute which you can use. There's obviously the two provision types, which is one provision SQL, which is more for dedicated compute for enterprise workloads, or Spark for obviously the advanced analytics use cases. And there's also an on-demand compute, which is serverless. So that's really useful in terms of querying and discovering data that you have available within the data lake itself. And why it's good for developers, because of obviously the various languages that it supports, right? So there's multi-language support from traditional SQL to Python, .NET, Java, Scala, and R. And then on top of that, which I'll show you later in the demo, is everything's wrapped up within a single studio where it has a GUI interface, and it just allows users to sort of have all the service planes within the same environment. And it's purely designed for all-purpose advanced analytics and also machine learning and business intelligence as well. And just recently in Ignite, there's been a huge announcement around Azure Synapse pathways. So what that is essentially it's an executable which you can install on various on-prem environment for SQL, and you'll be able to scan your database objects purely based on your various the database objects that you have, and it'll run an assessment and be able to automatically convert and optimize into T-SQL language in Azure Synapse. So the links are available there, and then I think the slide will be available for everyone that wants to review after, so you can check it out. So this is essentially the Synapse landscape in terms of using Synapse for advanced analytics across big data. So on the left, you have obviously all your various data sources, your business and customer apps that could be structured or unstructured in terms of log files, media, and object-based files itself. When the data gets ingested, there's essentially two patterns that you connect with Azure. There is a cold path and a hot path. So on the top, which is a cold path, which is more for batch ingestions, and obviously the bottom is around streaming and real-time ingestion of data itself. So for streaming, you obviously use something like Event Hub or IT Hub that's available in Azure. And then you have a streaming analytics service, which is a platform as a service, which you can write T-SQL to actually run queries across that real stream of data. So in a traditional Lambda architecture, what you'll do is also obviously from a real-time streaming perspective, you'll land the data into a data lake storage, and then you store that information for future analysis or future use cases. For the batch ingestion, you'll use obviously the data factory, which is the data integrate component in Azure Synapse, and that will allow you to have connectivity to majority of on various data sources and applications, and you can bring all that data in through more of a scheduled approach or a event trigger approach based on particular events, and you'll land the data into a single data lake as well. So from that, you'll run various transformation, which can be done using the languages which we discussed previously around Spark or SQL using Synapse itself. And then you'll push the data into a dedicated SQL pool for, if you have a petabyte data stored, and then you have various workload that needs to be processed at a quick turnaround time, then dedicated pool itself. And then from sort of the Spark component, you can run AutoML and push a lot of the machine learning capabilities to Azure Machine Learning Services that's made available in Azure, where you could essentially author various machine learning models. And then once the model's trained, and you can inference that in a container service, and then allow other web and mobile applications to tap into what you've built as part of the ML journey itself. Okay. So the next slide, we'll talk about essentially the ELT framework and why a data lake architecture is important. So one of the main things around data lake is the taxonomy is very important in terms of governance and control, and obviously access around the data lake. So on the diagram here, you have the majority of all your event-based, structured or non-structured systems. You have different types of ingestion patterns that you might collect the data, and obviously the data will land into a raw or landing zone. So the raw zone is essentially organized in the original format of the source, so you can have that integrity of data once it gets ingested. Normally you organize it by the source file name and essentially partition it by date, because you could have a large amount of data that's coming into the raw and landing zone. Normally you'll restrict access to your consumers in the raw zone, because it's really just for the ingestion or in integration with the sources itself. And then the next path is obviously, once the data is in the raw zone, then we might want to do various analytics or various use cases and want to do some massaging and transformation of the data so that it could be ready for consumption. So the efficiency is setting up a different zone, which is likely a trusted zone, where it could be consume ready and organized for business data and entities. So when in that zone itself, the data will be cleansed, it'll be transformed, and have various logic applied to it. And on top of that zone itself, you can actually offer it to consumer access. You can use various Azure AD and role-based control to provide access to various consumers that you have within the organization. And lastly, there's also, you can set up a various sandbox zone. That really provides an area for discovery, and it gives that organizations the agility of users being able to draw from various part of data, using applications to draw from the raw zone and data from the trusted zone. You can bring data together to do discovery, and essentially do various advanced analytics and also machine learning use cases that you might have. So in a high level, this is essentially the right approach to take to architect your data lake itself. And then as part of the ingestion pattern, in Insight, we have a proven method for metadata-driven ingestion patterns. We're a strong believer that metadata-driven ingestion is important in any organization. We've deployed our IP, which is our ingestion patterns, for over 50 different customers. And some of the benefits they offer is, obviously, one is open source. Everything that we deploy for customers is enterprise ready, and it's deployed within the customer's Azure tenant. So there's no lock-in in terms of we own the IP, the customers will open IP. The framework is extensible, so all the logic of the control is maintained within a control database, which can be extended if there are additional data sources that needs to be added, if there's new dependencies that's required, and then if you want to add various staging processes required for ingestion as well. In integration and app dev advisory, so what that means is all artifacts that we sort of deploy as part of the framework is integrated and stored within Azure DevOps for future CI/CD pipeline builds and essentially reusability for the customer itself. And then the last but not least, once all that process has been completed, it really does offer agility in terms of delivery and collaboration within the organization to sort of build and improve on the solution a lot faster in the future. Okay, so the next items we'll start talking about the metadata ingestion patterns and how do we actually structure a data pipeline efficiently. So if we sort of go back to the topic around data lake, you'll have a raw zone, which is essentially, like the data that's from the source. You have a trusted zone that could be converted into a Parquet file for optimum storage and column store, which can be massaged and transformed. And then you have a serving layer, which could be in Synapse or in a sort of database layer for consumption. So normally, traditionally, when we start building a data pipeline, it has various different activities, right? So we start off building from say source to raw, will be one copy activity, for instance, and then from raw to trusted, it will be another sort of transformational logic, which is another activity. So in terms of building that pipeline, there could be multiple pipelines developed in more of a horizontal plane, which you connect to the source, copy the data, and then transform and then put into trusted before it could be served. So over time, when we go down the path of building each individual pipelines horizontally, they could have issues around dependencies. So over time, when a particular data source from one pipeline needs to be made available in a raw zone before a transformation logic can start for a separate pipeline, for example, there's going to be a lot of refactoring that's going to be required, and then in order to continue to support this pattern. All right. So if we say, okay, if we remove the vertical kind of pathway and then trying to solve the problem, you're in a more of a horizontal plane. Sorry, I got it mixed up. This is vertical. Previously it was horizontal. But the idea is if you go for more of a horizontal plane, for a vertical plane, then you build the vertical plane accordingly to the various zones, right? So you build all your pipelines for source to raw, essentially bringing all your ingested data from the source systems into the raw and have that in a single pipeline. Once that's completed, then you run your raw to trusted, where you applied all your transformation logic across the board in a single pipeline, and then you go and stage that across, right? And then served. But then over time, it's the same. And when the business mature, there's going to be dependencies that arises. So now this time, there could be two dependencies across some of the transformation logic that needs to be required and executed in sort of a sequential order. So if we can't do a sort of on a vertical or horizontal, how should we approach it? The idea is obviously best practice to approach it will be to break the pipelines into more modular activities, and then have each activity become more parameter driven. So be able to feed in various values so that it can be reused for multiple use cases. So that's purely for your usability and really removing some of the dependencies in the future. And then to build an end-to-end, the best way would obviously start off small, setting up a couple of child pipelines to establish the metadata-driven approach. Normally, the child pipelines will have load dependencies. So if you think about, converting Excels to CSV, so that will be one child activity or pipeline. If you want to sort of copy a web service and convert to CSV, that could be another child pipeline itself. And then you'll set up a parent pipeline, which could consolidate and also orchestrate multiple child pipelines at the same time in parallel as well for efficiency. And then you wrap it around with a main pipeline, which will be able to orchestrate the complete ingestion pattern. And then with that, you can essentially attach it to a various trigger or event base for execution. Okay, so as part of the ingestion framework, I'll go through a demonstration, but just before jumping into the demonstration, essentially what this demo will achieve. It's on GitHub, as you can see, the link's there. So a lot of the artifacts is all available there. So if you want to grab it, feel more than happy to. We're trying to grab obviously COVID data, and there's essentially 4 different types of data sources. There's OData from the GHO, which is using API, using HTTP to grab COVID data reports, which gives you various counts of confirmed cases, recovery cases, and death. We're also grabbing some time series data for COVID in the last year or so. It's purely for part 2 as well, so we can actually use that data for insight purposes, and obviously a country code. So the country code is probably used for a lot of the geo visuals and mapping capabilities that's available. So the idea is we'll connect to these various data sources using the data factory, which is the integrate service in Synapse. Have a very simple metadata table, around 3 different tables in a controls DB, and then we'll drive that ingestion pattern into a storage, which is in Azure Data Lake, which will have a raw zone and a trusted zone. And then using the Spark notebooks that's available in Azure Synapse Analytics, we'll do a bit of transformation for the data that's been raw and convert it into more of a Parquet file that'll be pushed into the trusted zone. And then finally, everything will be done and pushed into Azure Synapse. And then next week, once all the data has been ingested as part of this session, we'll be able to go through some of the visualizations, and we'll go through Purview as well, and just sort of map out the various data lineages that's available, bring the sources in from source all the way to Synapse and Power BI, for instance. Okay, so with that, I'll close the slide, and then I'll jump into the presentation for the demo. Okay. So what I have here at the moment, so in the Azure environment, I've just set up essentially a resource group that has obviously the storage, and then we have the various SQL pool dedicated and the Synapse pool. If I was to click on Synapse here itself, when Synapse is connected, you have actually a primary ADLS Gen 2 account tied to it. So natively, the raw container that I have is tied to the Synapse itself. So we'll open up Synapse Studio, which is the GUI interface that's made available. Okay, and all the control planes are on left. You have manage, monitor, and the top 3 is essentially where you do majority of your work. So we could sort of start off with looking at integrate, which is essentially Azure Data Factory, just showing you some sort of the pipelines that's being built. So as I suggested, with the pipelines, I've got a couple of utilities pipelines. So I've got one which is essentially HTTP. The idea is that will connect to the various HTTP endpoint to collect all the COVID data. So the source here essentially, if we have a look, is essentially using some of the available data made from Johns Hopkins University. So there's essentially 3 sets of data made available, but what I'm doing is I'm using this utility pipeline to actually grab all 3, because each 3 has a relative URL. So for each data set, there's a different type of the data that we can grab from this base URL available. So I'll parameterize a lot of the relative URL so I can reuse this HTTP copy activity. And then obviously the sync itself, I'm going to use it and write the data into the raw zone. And obviously the source name and the file name is essentially parameterized. And if we have a look, for example, the utilities, there's also another one for OData. The OData is for the GHO to grab information around doctors and made available through OData sources. In regards to OData, there's a path which you need to sort of provide to grab the data set. So we've also parameterized that component. And essentially, the sync is also the same. We're bringing the data in from OData into the raw zone itself. And lastly, I've got a Synapse load. So this activity essentially is also parameter driven, where we could essentially, feed it, where the data is located, whether it be the trusted zone, the path of the data, and the source name. And then obviously from the trusted zone, the data set will be in Parquet file format. And then we're just pushing it into a schema and a table name within Synapse as well. And that's kind of the utilities. We'll have a look at just the control table that's made available. We can have a look through here. So if I wanted to write a process where I grab multiple HTTP endpoints, I can essentially create a single pipeline where I just do a quick lookup in my control DB, where I've set up a control table. So if I have a look at the table itself, essentially these are the sources that I want to grab, and I can achieve that through one single pipeline essentially. And then you have the various source name, the path, and obviously the destination where I want to sort of persist that data itself.
Hey, Chuang, sorry to just quickly interrupt. Would you mind zooming in on your browser? Some viewers are just having difficulty reading the Azure portal.
Okay.
Awesome. We'll see how that goes.
Oh, here we go. Maybe that's a bit better. Okay. Okay. So since we're processing multiple HTTP endpoints, we'll wrap that up in a for each loop. So the records will return sort of 5 HTTP activities that we need to copy the data from, and then the output will be parameterized into an input for the for each loop essentially. And then from that itself, we could call a sort of execute pipeline activity, which effectively is the HTTP utilities. And then we'll pass the various parameters across the board. So if I was just to run it now, so that will essentially bring in the HTTP data into the raw zone of the data lake. We'll just, as you can see, it's executing at the moment. So for a lot of the pipeline execution, that's essentially a platform as a service. So the cost-wise is pretty much executed purely based on the execution through the Azure Data Factory. There's no sort of compute tied or dedicated for executing these pipelines. Okay, so we move obviously the HTTP data into the raw zone, and we can just essentially go and have a look to see the data. So you have your dedicated compute within the data panel, and then in the link you have the various data lake Gen 2 storage, and we can go in and look at the raw zone itself, and we can see some of the data that's been processed just now. Yep, so 127, that's recent as well. What's really good about sort of Synapse, you can use the serverless sort of SQL to actually query the data that you have there, like how you would within sort of SQL Server, and you can run it and you'll be able to get the data into more of a tabular format already. So the reason it's running slow is because I've got a really small compute which I provisioned, because I don't, normally you could sort of scale up, but the idea is, as you can see, you can query the data yourself and it's made available. Yep. Okay, and then we'll go through another transformation logic where I've got once the data that's made available in the raw zone, we can do some form of transformation. So, for example, for the country code, I've written it just a sort of simple notebook that will allow to connect to the CSV file for the country code in the raw zone, and then do a couple of transformations, for instance. So the idea is you can parameterize a lot of your data in the notebook by setting up a parameter cell, and then what you can do is using the integrate, which is the data factory component, you can pass various parameters to these parameters names, and it will overwrite the parameters you have in this field. And what's good about that is essentially you can reuse the same notebook for various sort of use cases if the transformation logic remains the same. So while this is warming up, I'll just go through some of the logic that's within the code itself. So the idea is I'm importing the PySpark libraries for the SQL, and then I'm creating a connection path to the raw zone, which is obviously set up from the parameters at the top. I'm reading the CSV files for the country data that was ingested into a data frame. And then from the data frame, I'm just selecting the distinct values using the country ISO code itself. And then from that, I'm writing it back to the trusted zone, but I'm writing into more of a Parquet format into the trusted zone itself. In the meanwhile, while this runs, I can go through some of the other notebooks as well. So this is quite similar, obviously starting off with a parameter field. And the idea is this is the COVID data reports where we have all the various counts of confirmed death and recovery data set. And what I'm doing is the same sort of transformation where I'm grabbing the file from the raw zone, reading it into a data frame, and then I'm selecting the right fields and grouping it by country, and then summing up the fields purely based on confirmed death and recovery, and then renaming some of the columns, and then writing the data into Parquet into the trusted zone in the data lake itself. And the last transformation is pretty much the doctor counts. So same sort of parameter tab at the top, grabbing the data, writing into a doctor data frame. And this sort of file structure didn't really have a descriptive header. So select, group by, and obviously renaming it by the country and the year, and essentially getting the doctors, how many doctors are available per 10K based on the population itself, and then writing the data into the trusted zone itself. So as you can see, the cluster took, because I didn't start it before the demo itself, it started. Now this job is actually executed, and then we can just have a look. So this is the country, for instance. So in the trusted zone itself, country code, yep. And what we can do is so obviously it's in Parquet format, so it's distributed in column store, but with Synapse, you can actually highlight a couple of them, and you could sort of load to the data frame, or you can bulk load into your SQL Synapse analytics as well. So it's quite sort of powerful in terms of what you can do from the interface itself, and then okay. So that covers some of the pipelines that's sort of driven here, where we have HTTP, we have the OData to raw, we have raw to trusted for the three transformation logic that needs to be applied across country data, doctor data, and also the COVID data. And then I've also got a lookup that will pretty much push all the Parquet files that's in the trusted zone into Synapse itself. So essentially using the control schema where we can define the source, where the source location is, and also the target schema in the target table itself. And we can run a select the pool. And that will process pretty much all the various Parquet sort of entities all at the same time, essentially. Okay, so once that's completed, we can actually go back to our dedicated pool, which is the data here, and we can see the tables of the data that's been populated. So I have the country code here, I have the various doctor count aggregated by the region and maximum year, for instance. And we also have obviously the code data where we aggregated all the country regions for sum of confirmed death and recovery. So that's all made available and pushed into the Synapse pool at the moment. Okay. So once you actually select the SQL query, it actually gives you the query here where you can run your serverless, the SQL scripts all made available, which you can edit and also save for future use as well. Okay. Okay, let's go back to our pipeline. Now we've sort of gone through the utility functions. We've gone through the next parent list of pipelines, and then essentially we'll have a main pipeline that will pretty much execute. So I tried to execute this before, but the OData connector at the moment was down. So if you have a look here, it says the pipeline itself. The service mode is actually down at the moment. Let's see if it's working now. So the idea is that this pipeline wraps all the various pipelines that's previously created, where we fetch the data from HTTP, we'll grab the data from OData, and then we'll run all the various transformation using the Spark clusters, using the notebook, and then have a bulk insert of all the transformed data that's in trusted zone into Synapse table itself. Okay, perfect. The OData is working now. Just let this pipeline run. And that should sort of gone through all the processes that we created. And I'll just have a look to see if there's any questions.
Yeah, so that was a great demo, Chuang. Thank you so much for that. So we've actually had a good amount of questions from the audience as well. I guess the first larger topic being metadata-driven ingestion and why. So why metadata-driven ingestion as opposed to other methods at a quick high level?
Yeah, okay. So I think the main purpose is obviously having the reusability for a lot of the code base, and it's probably the number one, because obviously what I've sort of shown is that I had sort of one activity for HTTP and I reused it for probably 5 different endpoints. So the idea from enterprise is you can have multiple systems but leveraging on the same connector. And the idea is you can use a single sort of activity and you can rerun it over and over, and you can run a loop and you can run it all together, all in the same activity. And having the metadata approach is that you can define your sources, where your source and your destination as part of using just a single table, and then using various lookup or metadata lookup activities in Data Factory, and then using that value to parameterize your pipelines. So essentially shortening a lot of the development times, having the reusability is key. And then, you know, from a sort of logical pipeline perspective, you don't really need to change some of the pipelines if they're working as sort of raw to trusted to Synapse, for instance, and then you just want to have a new data source included. All you really need to do is add a new connector within the Data Factory pipelines and add a new record into the control database, and then you can reuse what you've already built, right? And then obviously there's going to be transformation logic that needs to be applied. Then that's an additional piece of logic that you need to add, but you could incorporate that within, you know, all the main pipelines itself. So that's probably the two main sort of reusability and extensibility, and less time to refactor some of the development that you've done.
Okay, awesome. That makes sense. There are a couple of questions around the framework as well. So the first one being whether it's open source or proprietary, and if it's open source, can we get a link? And 2, does the framework currently support auto generation of data lake metadata files from the ETL metadata?
So the it's not open source, because obviously what I built is really just three tables just for the demonstration. The idea is just to show that the metadata approach, but Insight has its own framework, which we deploy for customers. So that's not public information that's made available through any sort of GitHub or any repo. And the second question, which you mentioned, Amanda, can you just repeat that? I didn't get that. That's around the metadata.
Yep. So it was, does the framework currently support auto-generating data lake metadata files from the ETL metadata that you have in Data Factory?
Yeah, I don't know what that question means. I'm sorry.
Okay, all good.
Yeah,
so whoever asked that
metadata
question, if you could clarify in the Q&A, but for now we'll just move on to the next question. So there was a really good one here as well about domain-driven pipelines. So that's something they haven't had the chance to experiment with yet on Synapse or Data Factory. So that is splitting up pipelines into domain object pipelines, such as for a bank, it could be loan, user, and account, as opposed to splitting that into data types or transformation types. So the question is really, have you had any experience here, and what are your thoughts and opinions?
Yeah, I think that domain approach can work as well. Not splitting it by business logic. The pure base, obviously, with this metadata-driven approach is driven by the connectors or the ingestion. But that's not to say you can't reuse it for sort of domain reusability as well, because what I built is really just 2 to 3 tables, which does look up and then use that metadata to drive pipelines itself. But when you have a proper framework, you have essentially, you can structure the relationship of how that control database will look like for your organization, whether you want to split it by domain, whether you want to, because essentially you can stage different things and have various sequence in the database, and then using a lot of the capabilities in the Synapse ADF integration pipelines to build the, exactly how you want to look.
Okay, great, thank you. Another question is, does the control database go down to the column field level to permit column renaming and mapping?
So the control database is actually, normally hosted not in Synapse, but into more of a separate database itself. What we do is we use a sort of lower tier DTU or Azure serverless, because obviously users will not have to have any interaction with that control DB. It's purely used for ingestion. So only sort of the Synapse integrator or Azure Data Factory will do a lookup against that. But if you want to essentially go down the path of driving a logic to rename fields or rename column fields, you could essentially put that in a transformation logic or piece to actually do that and orchestrate it using the pipelines and the way it's built.
Great, okay. Another question is, are there methods available that reduce the number of copies you have of your data, as making multiple copies can be cost prohibitive, especially at larger scales?
Yes, I think that really depends on, I suppose you can do, for Synapse, there's probably 3 methods. If you want to copy data into Synapse, there's obviously polybase, there's a copy activity, and there's also bulk inserts. So it really depends on, the data that you have made available and how you want to sort of achieve that from a cost perspective. And, normally what we sort of go through is you can do, I suppose, for each loops that's available in one of the activities here, for instance. And then you can run sort of like a parallel process across different types of data, and you can run it all together at the same time as per activity itself. So that could potentially reduce some costs if you're running multiple copy activity at the same time.
Okay, great. So essentially there are multiple methods, but the exact one will be dependent on the customer themselves and their requirements and appetite for spend.
And the data and the source data that it comes from as well. Yeah.
Okay, great. So that's all the questions we've gotten so far. So we'll give them a bit more time to either ask or hold their peace. But as we wait for potentially more questions, Chuang, did you want to walk us through some of the, exciting initiatives or use cases that you've worked on in the data ingestion space recently? Obviously obscuring any sensitive information, but just so that our audience gets an idea of, how they can apply this to their own companies or projects.
Yeah, I think one of the most exciting things is essentially really having the ingestion pattern built for customers where they could operate the ingestion pattern themselves in future. So not having to engage us to sort of support and adding more data sources in, it really enables sort of agility within the organization. And what's some of the sort of exciting things I've seen is once the ingestion pattern has been set in place and they know how to operate that ingestion pattern, they can essentially, have the ability to grab any sort of data that's made available through external, on-prem, or whatever they have access to, and quickly get that data into a sort of pattern for a lot of the advanced analytics use cases. So we're kind of working with, universities and to essentially put together, the ingestion patterns that's made available, and their developers actually bringing different types of data just on the day itself. And then straight away they're going down the path of sort of doing feature engineering on the data and looking into more of a advanced analytics kind of use case to determine student attrition. So that's quite sort of exciting to see that, back in the days where, when you have a lot of data sources, it just takes months to essentially connect, get the data, where now you can, if you have this pattern, you can essentially extend it out and bring that in within a few hours. And then with the right services that's on the cloud base available to the internal members and the staff, they'll be able to, grab the data and start developing different sort of and training different models and just testing out capabilities within the organization. I think that's very, very exciting.
Yeah, sounds really cool. Okay, the next question is there any out-of-box pipeline component that does decoding and encoding, for example, data encryption and compression?
Not that I know of from sort of a data factory lens. You could essentially go down the path of using a notebook, for instance. So you can use a notebook and have a look at in terms of what sort of library or pre-built sort of imports you can actually use, and then potentially load the data in and use the available library to actually encrypt or decrypt, and then write it back to the data lake itself. And you can still orchestrate the notebook through the orchestration and then the integration layer as well. So I think that's one way. Just thinking off the top of my head at the moment.
Right, sure. And talking about the other ways where we can use Synapse, is this something that we could possibly use to reduce data ingestion costs? So the audience member has said that using Sentinel costs a lot just because it picks up so much.
What is it, a Sentinel?
Oh, Azure Sentinel?
Okay. Yeah, I'm not too familiar with Sentinel, but in terms of, you could, with Synapse, obviously, you could optimize by, with this sort of, I'll just bring this up. So what I have is obviously you have your dedicated compute, which charges by, the hour, for instance, when you consume. I suppose if you can always go down a path of doing an optimization approach where you understand, the concurrency and the usability, when to scale up, when to scale down. So essentially optimizing the costs for your organization. So if you know that the workload is heavy between 9 to 10, then you'll scale up. And then if it's idle for 2-3 hours, then you can just pause the compute, which means that you don't have to actually get charged during that period. And a lot of that could be orchestrated using REST APIs that's made available to sort of pause, scale up, and also scale down the sequence. And you can orchestrate it, a lot of that with the data factory pipelines to optimize your costs, for the longevity of the solution itself.
Brilliant. I think it's always important to understand cost optimization techniques whenever we foray into new products.
Exactly.
What I'd also add onto that, though I'm neither an expert in data or Sentinel, is that you do really need to consider the different types of logs. So whereas this is information that's actually going into your EDP and you're using to inform key business decisions, the data that often goes into Sentinel are security and auditing logs that are very much for a different time and place that you'll do different things with. Another question is also, so SQL Server has also provided a lot of metadata for describing and cataloging data sets and models. So how does Synapse actually compare to SQL Server in this respect?
So I think it's very different if you want to compare the two, because obviously Synapse is what they call an MPP database, so massive parallel processing. It can actually use for obviously distributing your data into 6 different partitions where you can query, you can insert a lot faster compared to the SQL Server. So that's kind of the primary difference. And then with Synapse itself, obviously you have the capability of native connectors that's made available to a lot of the Azure components. And obviously you can have a serverless query of a data lake, which is essentially unstructured. You can query unstructured data that's made available, whether it be in Parquet files, CSV, or JSON files. So that's something that you probably can't do back in the days with sort of SQL Server, where everything needs to be relational. So that's probably another advantage of the two. So that's kind of what I can sort of think of from the comparison that I have. Yeah.
Perfect. Thank you so much. So I think that's about all of the questions we have today. Obviously, if you think of any questions in the meantime, Chuang is also joining us next week, so you can ask then. But yeah, thank you all for tuning in and looking forward to the continuation of advanced analytics for developers, same time, same place. Not that, you know, we're actually in physical meeting rooms this time next week. Thank you, Chuang, for the awesome presentation and for everyone to tuning in.
See you next week, guys. Enjoy your day.